Hi, Pre-Calc. This is Miss Jensen, and we are going to talk about graphing hyperbolas. So, hyperbola equations, the equations for hyperbolas look really similar to ellipses. So if you kind of look at this example up here in the rectangle, the main difference is instead of a minus or instead of a plus, there is a minus. Okay, so that's kind of the key to telling, like if you look at an equation, if it's a hyperbola or an ellipse. So just like an ellipse, it has a center. Just like an ellipse, it has foci. The difference is that with the equation for the hyperbola, you're adding a squared plus b squared rather than subtracting. So one of the ways I keep it straight is, remember with ellipses, this was a plus and this was a minus. Well, now it's reversed. A hyperbola has a minus in the equation, but then it's a squared plus b squared. So that part is always the opposite. As far as the vertices go, kind of one key difference is that there's only one set of vertices. You're still going to do the same thing you did before when you're graphing. You're going to kind of take the square root of whatever is under x, and you're going to go right that square root, left that square root, up that square root, down that square root. And then you're going to make a rectangle instead of an ellipse, but it's just dotted. It's almost like an asymptote. It's just kind of a guide for our graph. But the vertices only come from the first term there. So this is where the vertices come from. There is only one set of vertices. And then A is the distance from the center to the vertex. I should have said vertices, but it's just this distance, okay? We still use the b squared to go up and down, but that's just to make kind of an almost like an asymptote-like rectangle. All right, so speaking of asymptotes, asymptotes also are guides for those curves. So when you look at the graph, this dark part here, that's the actual graph. Everything else is just asymptotes or the rectangle, kind of a guide. And this is the equation. It's going to make more sense once we do some examples, but we're going to go y minus the y value of the center, x minus the x value of the center. So kind of like we do up here, where we're going x1, y1. Oh, and actually I should say h and k for that instead. Okay, so this is h, oops. H, just like before, goes after the x. K goes after the y. All right. But if we kind of go back here, this is the center. This is the x value of the center. This is the y value of the center. And then this is going to be the slope. So it'll make more sense once we do a few problems here. All right. This is also another equation. So it's like, well, what the heck is the difference from the last one? Well, if you notice, the main difference is here, y is first. So with ellipses, it didn't really matter if we put x first or y first, because x plus y is the same as y plus x. But here it matters. So the first one is how you get to the vertices. So this is how you get to vertices. And remember, if it's under the y, you're going up, down. So that just means that that's where the vertices are. We still go right, left, to kind of help us find that rectangle. And that would be, right B, left B. Oops, everything's going a little crazy here. So right B, left B. But this here is the A is how we get to the vertices. And because that it's whatever the number is under the first term, the square root of that, that tells us how to go up, down for the vertices. Okay, then foci, if you notice, the foci here are always inside the curve. So if we go back to the other one we were just looking at, the foci are inside the curves there. So that is always true. The foci have to be inside those curves. Finally, one last thing I want to talk about is the transverse and the conjugate axis. So the transverse connects the vertices. Okay. The conjugate axis goes through the center, just like the transverse. So I guess we should say that also with the transverse. Connects the vertices and goes through kind of that center. So the conjugate axis also goes through center, but does not connect vertices. All right, so this is the one that connects the vertices. So when we get to writing equations, some of the ones say, like the transverse axis is horizontal. Well, that means you know that to get to the vertices, you're going to go right and left, and that the x would be first. That's kind of looking a little bit ahead, but it does kind of help us out with that a little bit later on. All right. We're going to move on to some examples because it'll make more sense once we do some examples. So y squared over 4 minus x squared over 1 equals 1. So our center we find exactly like an ellipse. So this is as if I had y minus 0 squared over 4 minus x squared over 1. Okay. Oop. Except I want to put that as x minus 0, just so it's a little easier to see the center. So remember, this is the x value. So because it's x minus 0, the x value is 0. This is the y value. Because it's y minus 0, this is 0. So the center is 0, 0. Our vertices come from here. So y is up, down. So that's where our vertices are going to come from. It's going to be the square root of 4, which is 2. So that a is equal to 2. So all that means is we go up 2, down 2. Now if we're writing that out, remember the center is 0 and it's the y that's affected. So what did we just do? We went up 2, down 2. So to the y value, we added and subtracted square root of 4, which is 2. So our two coordinates are 0, 2, and 0, negative 2. Okay, now we're still going to go right, left. So we're going to go right, left, the square root of 1. Square root of 1. So I'm going to go right 1, left 1, because square root of 1 is 1. But that just helps us with our little rectangle. So I'm connecting all the vertices. Well, the vertices and kind of what we got by going right, left. I shouldn't call that those vertices. But I make a little rectangle. So up 2, down 2, left 1, right 1. So just like the ellipse, except instead of making an oval, we make kind of a dotted rectangle. The foci, so the foci, because the vertices are here, if I were just going to sketch this graph, because the vertices are here, this is what my graph is going to look like, which means my foci have to be inside the curves, which means for the foci from the center, I'm going to go up and down. I'm going to add and subtract to the y's. All right. So this is going to be plus and minus. So if we're adding and subtracting to the y's for the vertices, we're adding and subtracting to the y's for the foci because it has to be above and below the foci. But what do we have to add and subtract? Well, this is where this c squared equals a squared plus b squared comes in. Now remember, this is our a squared. So a squared is 2 squared. Our b was 1. And so c squared is 5. And c is the square root of 5. So that is what we're going to add and subtract for a foci. So if you imagine square root of 5 is 4 point something, oh, keeps going back to that one. It's just right above and below where the vertices are. So you don't have to worry about, it's like, oh, it's got to be exactly 4.1. Well, you can't see that, especially in such a small graph. Then the last thing I want to do are the asymptotes. So if I'm going to draw the asymptotes, I'll do that first. I would just go through the corners of the rectangle, and I want to make sure and go through the center. But notice I'm just going through the center and through the corners of that rectangle. And then if I really want to darken my graph, this is my actual graph. Okay. Looks a little bit funky. They're a little bit crooked. But for the equations, this is kind of the shell of the equations. So I'm going to put in the center x minus 0, y minus 0. Maybe this, remember this is x, this is y. And then here I'm going to put in the slope. And the slope is always the square root of whatever's underneath the y over the square root of this. Well, honestly, what I do for the slope usually is I just look for the rise over run of the rectangle. So if you look here, this is 4, right? This is about 4 here. 4. And this here, right, left, is about 2. So 4 over 2, which reduces to 2 over 1 or 2. And that is my equation. And you can just leave it like that. I know that looks kind of silly, but if we simplified that out, it actually is just y equals 2x, positive negative 2x. We should have a plus minus. So if you kind of look at those blue dotted lines, this one is y equals 2x. So y-intercept of 0, slope of 2. This is y equals negative 2x, slope, y-intercept of 0, slope of negative 2. Okay, let's try another one. This again has a center of 0. So this is x minus 0. This is 9. This is y minus 0 over 16. So my center is my x value is 0, my y value is 0. My x is 0, my y is 0. So that's my center. This time, this is how I get to the vertices. So from the center, I'm going to go right 9, square root of 9, which is 3. And here, I'll do this color here, right 3 and left 3. Those are the vertices. I am going to use this as well. Underneath the y means I go up and down. So I'm going to go up 4, down 4. And then that creates this rectangle. but the only actual vertices are at -3 and +3. If I want to draw in my asymptotes because they go through the corners, I can actually pretty much draw my graph already. Goes through the vertices. So now I have an asymptote, I have a guide. We still don't know what the foci are, but we'll do that here in a minute. So the vertices, how did I get to the vertices? I got to the vertices by the x's. So I'm adding and subtracting to the x's. The y stays the same. So this is plus minus square root of 9 is 3. So you can see that this is 3, 0, -3, 0. The foci, again, have to be inside here. They have to be somewhere inside the curves. So that means I go right, left. So to get to the vertices, I added and subtracted onto x, and that's going to be the same with the foci. How do I find the foci? Well, we're going to go a squared plus b squared. So basically, square root of 9 is 3 squared. Again, once I squared, it's just 9 plus 16. Not 3 squared plus 4 squared. That is 25. So if I take the square root of both sides, that is 5. So I'm adding and subtracting 5. So that's a little bit easier for us to see anyway. So from the center, I would go right 5 and left 5, and that's where the foci are. For the asymptotes, so the y is on the left, and for a regular linear equation, it's always y equals slope x, and that's the same here. So the y comes first. So just remember that after the y, you put the y value so I'll put a 0 there. After the x, you put the x value. So I'll put the x there. And then this is, of course, the slope. So if I do the rise over run, this is 4 plus 4 is 8 over 3 plus 3 is 6, 8 over 6, which reduces to 4 over 3. So this is 4/3. Okay. That is that. Let's try some where the center is not 0, 0. So here, our x is first, so our vertices come from here. Our center, because x is first, this is going to be +5. This is going to be -1 for the center. Because we're going right left, well, let's, I guess, first do the center here. Ugh. So it's +5, 1, 2, 3, 4, 5, -1. That's the center. And here, this is the vertices. We're going right, left. So I get that by taking the square root. Square root of 25. So our A is 5. Our B is square root of 9, which is 3. So I'm going to go from that center, I'm going to go right 5, left 5. So here we go. This is still -1, but here we're going to add and subtract 5. Yep, not 0, 5. I'm thinking ahead that 5 plus 5 is 10, -1. Notice this is 10, -1. 5 minus 5 is 0 comma negative 1. And notice that is 0 comma negative 1. So instead of writing it out as two separate points, a lot of times we just write it the plus minus. Same with the ellipses. Okay, for the b's, I'm going to go up and down 3. So I'm going to go up 3, down 3, 1, 2, 3, and that's going to allow me to make my little rectangle with between the vertices and that and the going up and down. I'm going to make the asymptotes. All right, well, hopefully you can make them straighter than I just did. Okay, I better fix this. This looks a little... All right, so those are the asymptotes. And just to kind of darken where the vertices are, remember these are the vertices here. So if I kind of draw those in, it's going to follow the asymptotes, and the vertex of each, the left and right side is that in pink. So I guess if I jump down to asymptotes, I'm going to go x minus, so remember the x value of the center is 5, and the y value of the center is negative 1. We'll kind of clean that up after. If I find the rise over the run, the rise is, this is 1, 2, 3, 4, 5, 6. This is 5 plus 5, which is 10. So it's rise over run. If I clean up this equation, 6 over 10 reduces to 3 over 5. And, you know, if I distributed this is supposed to be a 5. If I distributed this 3/5 and subtracted the 1, I would get an equation for this line, an equation for that line. But usually we just leave it like that, right? For the foci, c squared equals a squared plus b squared. Well, a squared is 25, b squared is 9, which gives us 34. So c is the square root of 34. And remember, they have to be kind of inside here. So that means we have to add and subtract to the x's, because from the center, we're going right, left. So this 5 stays the same, and this is a negative 1. So this is plus minus square root of 34. The square root of 34. 5 plus 5. Okay, we're going to do one last one. I know this is getting a little long. I think hyperbolas are probably one of the harder, it's one of the hardest ones as far as the graphing. So they do take a little bit more time. But we're going to first put this in general form. Okay, so when I put something in from general form to standard form, I'm going to start by grouping the x's, grouping the y's. So I'll group the x's, 9x squared minus 54x. I may as well skip the blank right now. I'm going to group the y's, minus 4y squared minus 40y minus 55 equals 0. Okay. I'm just going to group those, but now I'm going to factor out the coefficient of x squared. I'm going to factor out that 9, and I'm left with x squared. 54 divided by 9 is 6. Okay, and now I'm going to put a blank there. All right, now out of these, notice that this is negative, so I'm going to take out a -4. -40 divided by -4 is +10, so I just factored out a -4. I'm going to leave a blank. And finally, I need to add that 54 to the other side. So this, if I add 55 to both sides, that's going to cross off. And then we've got to put a blank and a blank. So now we're going to half it. So half of -3, or -6 is -3. And we'll square it. And we'll add it to both sides. We're going to do the same with the y's. I got to clarify something there, because it wasn't quite as easy as that. We half it and we square it and we add up to both sides. But really, what did we add to both sides? This is 9, but notice that there's a 9 on the outside. So we have to do 9 times 9. Really, when I put this 9 here, because there's a 9 in front, what I really added was 9 times 9, which is 81. Okay, so on the other side, if I half it and square it and add it to both sides, well, I just added 25 supposedly, but I've got -4 times 25. So I really added a -100 to the other side. So if I were to simplify the the right side, 55 plus 81 minus 100 ends up being 36. So this all simplifies to 36. On my left side, I've still got that 9 on the outside. So I have a 9. But this all simplifies to x minus 3 squared. Now this is a -4. This all simplifies to y plus 5 squared. Now we're almost there. Remember, if it's in general form, it's supposed to equal to 1. So just like the ellipse, we're going to divide by 36. Divide by 36. Divide by 36. And now I have to simplify that fraction. 9 over 36 simplifies to 1 over 4. So this is x minus 3 squared. So again, kind of what I just did is this simplifies to 1 over 4. This is a minus. This is y plus 5 squared. But 4 over 36 simplifies to 1 over 9. So it's almost like the 4 and the 9 switch places. But finally now, this is in standard form. So now we can go and we can find the center. So the center, x is first, y is second. So our x is +3. Our y is -5. Let's go ahead and plot that. This is 3, 2, 4, 5. There's the center. Now, because the x is first, we're going to add and subtract to the x's. So this is 3 plus minus . So we're adding and subtracting to the x's. So square root of 4 is 2. So this is our a is the square root of 4, which is 2. our b is going to be the square root of 9, which is 3. But we're adding and subtracting 2 there. So to the right we'll go 2, to the left we'll go 2. Up and down, we're going to go from the center up 3, down 3. Make our little rectangle. And we'll go through the corners of the rectangle and through the center. Those are our asymptotes. Again, the vertices, it's kind of hard to see there. We went right and left for them. So this is my graph. And I know the foci have to be in here somewhere. So that means this. Just say I spend a fair amount of time with these colors, don't I? I don't know if it's worth the time. Okay. So the foci, plus and minus what? Well, this is where we have to go. C squared equals a squared plus b squared. So that's 13. So this is the square root of 13. So this is the, and pick a color, any color. Go do this. Oh, well, yeah, that's fine. Square root of 13. Which is, let's see, square root of 13 is about 3.6, something like that. We just need to know kind of approximately. You can do it on your calculator. So from the center, we're going to go about 3.6 to the right and to the left. So we're going to go 1, 2, 3. So it's just a little bit in there, and left 1, 2, 3. Just a little bit to the left there. Let's see, maybe I did that a little too far out. 1, 2, yeah, it's about right there. 2, 3. Yeah, I guess we could pull this out a little bit more. Anyway, we don't need to get too fussy with it, but whatever the square root of 13 is, we should go that far to the right and to the left. Okay. Finally, the asymptotes. Y minus, plus minus, and x minus. So this is the center. So our x goes here, our y goes here, and our slope, rise over run. Well, the rise is 6, and the run is 4. So 6 over 4. Now this simplifies, if we want to clean that up a little bit, to y plus 5 equals positive negative 3 over 2 x minus 3. Okay, so that was a lot, but that is graphing hyperbolas. We're going to have one more section. It should be shorter, but it is how to write equations for hyperbolas. If you have any questions, make sure and ask your teacher.